Hi guys, welcome to the new video of this Linux tutorial series. This video will be a bit long compared to other videos. The reason being this video is all about the partitions and the related concepts. So basically from this video only you will be able to understand the concepts like LV, BG, what are those concepts or what is PV. So basically if you calculate according to exam or if you think according to exam or there are two ways. Basically in the real world creating a partition and other multiple ways or understanding the right concept is very important if you want to achieve something great or if you want to debug or troubleshoot the issues. But if you compare with respect to exams, in the exam the partition question will be covering around 10% of your exam questions basically. So you can think of like if the exam is of 300 marks, so the 40 or the 50 marks paper is with respect to partitions, like increasing a partition, resizing a partition, multiple things. And by without understanding any partition concept, you can't understand the concept of LV, VG, and PV. So extra 5 to 7% in the exam will be the weightage of this LV, VG, and PV. So you can think of like total 80 to 85% or 80 to 85 marks will be taught from this video and the coming next video on the VG, LV, and PV. But you need to understand what is partition and other things before understanding the LV and other things. Okay, so let's start. So first, I want to tell you that there are two types of hard disk. Basically, one is the SATA hard disk that normally we are using from very last few years, and another is magnetic that you know by the name called SSD. So we are not discussing with the magnetic tape hard disk. SATA hard disk is something like you have a hard disk, okay, it's like that, okay, and inside that you have lines. Not these lines are drawn, but I am just want to visualize you. And one header is running, okay, and somewhere if I show you the hard disk diagram, okay, let me open it. So this, yeah, see, this is the type of hard disk. So there are few this type of disk that you can see on the silver coated, and there are the layer of this list disk, and the top of it there's a this header is running. So what happened, how the data is read by the hard disk is this header keeps on moving toward the disks, okay, continuously with some speed that is known as RPM speed. So when you purchase hard disk, you will see 4000 RPM hard disk and something like that, okay. And how data is stored is the silver plated or the silver disk you can see on the right of this like a CD. So on that particular disk, on that particular silver disk, the header will create a hole, okay. Now what does it mean by create a hole is if you think it like this is a paper, and on this paper there is a hole, then plain paper, then hole, then again plain, then in the down somewhere we have plain, then hole. Then hole in the disk is like creating a hole with the help of like some tool with the help of this header downside. So the hole in that disk is means the value is 0, and if the disk is plain and the silver disk is plain, that means the value is 1. So that's how the header will store a value and read a value from the hard disk. One thing. Second, where the values will be stored. So these are the disks, okay, and header is there. Inside this disk, you will not visualize it from the image, but yeah, some partition or some spaces is created like this. This space is known as sector. One sector is equals to 512 byte, okay. This is the size of one sector by default. We can change the sector size also, but yeah, this space, if you see between these two spaces, this that I am highlighting, this one thing is known as sector, and on every disk, on the layer of disk, we have the sectors. Basically, the partitions also. We have some spaces like this separated by something. Okay, this is known as sector. Now the question arises: why we need partition? What is the need of partition? So basically, to store data permanently, that I already told you in the last few days, that if you want to store a data permanently, we can't use RAM or memory, we have to use a hard disk, okay. And one more thing, if you don't gone through my video of types of storage, that is not only related to Linux, that is also related to cloud also. So there I explained you there are few types of storage. One of the type is block storage, okay. So you can only create a partition if the storage type is block storage or if the device is block device. If the storage is object storage or file storage, you will not able to create a partition. The reason behind is you can watch through that video of mine, the types of storage. I will share the link in the description also. So yeah, to store the data permanently, we need a hard disk, and that's what the use of hard disk. But one thing you want to understand, or you know, that as a human, we are only interacting with the operating system, and behind the scene operating system there is hardware. If you don't know the layered architecture, I have a second or third video on the channel regarding the layered architecture of the operating system. What is the architecture of operating system? How the things are working. So as a human, it's not possible to interact directly with the hardware. Maybe that hardware is your mouse, some or maybe speaker, maybe RAM, and maybe it's hard disk. So it's not possible with the human to interact with any of the devices or any of the hardware. That's why we have a layer called operating system, and behind the scene we have a hardware, and as a human we are only interacting with this operating system, and then on the behalf of us operating system is interacting with the hardware. So That's why we have to create partitions in the hard disk, because there is a golden rule basically. You can think of it a golden rule. Now what does golden rule means? If you want to create any partition, if you want to use any space or any hard disk in the world, maybe on Windows or Linux or Mac, anywhere, on any operating system, doesn't matter, or on the cloud also. Okay, so there are the fixed set of steps you have to follow every time to use any hard disk or use any partition. So partition is nothing but some space in a hard disk. So like this is a hard disk, and creating space inside this, these are the three partitions, nothing but it's a space only in the hard disk. Why we need to create a partition, I will explain you, but before that you need to understand that as a human we were not able to interact directly with a hard disk or any devices. So if you want to interact with hard disk or the partition, we have to follow certain steps. Now what are those golden rules or certain steps? I will tell you. So for every hard disk or any block device anywhere in the world, in the cloud or in the on premises, on the Windows, Linux, Mac, doesn't matter, first thing what you have to do with the device is you have to create a partition. That we're going to see in this video. How we can create a partition? Using fdisk command. We'll explain you this. Second, we can't use partition directly. Okay, we have to format the partition. Now what does it mean by formatting a partition? I will explain you. It will create something called inode in the background. What inode is, how we can see inode, I will explain you. Third, we have to mount that formatted partition on some folder. Now why we are mounting that partition on some folder, why we are not using that partition directly? So in that video only, while accessing what human can do with operating system, I explain you that human cannot interact with any other thing except the file and the folder. If you want to accept a hard disk, you will not interact with it directly. There is no way in the world. So to interact with it, there is a way called, we have to mount that hard disk on some folder. And if you told me like we are interacting directly with speaker and mouse, no, we are wrong. We are interacting the drivers with their drivers. So if mouse is working, as a human in the operating system, we are only accessing the driver of that keyboard, mouse or speaker. Then operating system will interacting with the device. We are not interacting directly with the devices. This is one thing. So let's come back to the things back. It's all about the theory basically. Now let's move to the hands-on. So step first, what we have to do is we need obviously a hard disk, or I can say more than hard disk, a block device. A block device is nothing but a hard disk only in which we can do a partition. So step one is like creating a partition. Now let's see how we can create a partition. So very quickly I am moving to my screen, and if I show you the command called lsblk I already explained to you. It will show the block devices, and you will see here I already attached one hard disk to my operating system. Okay, that is having a size of 8 gigabytes. And it's not mounted anywhere. That's why I can't use this. There is no way. Second way is fdisk command. I can use an option called -l. -l means list all the block devices or list all the file systems. Okay, it listed out. See in SDA, if you check here, so disk is SDA, size is this. Second, how many partitions are created from this to this. And if you see this number I already told you is a sector number basically. And if you want to calculate the partition size, so the way is the blocks, this number total and start and end. If you minus from end and start, you will get these blocks, and every block is having a size of 512 bytes. So if you calculate this, here also you can see sector is 1, 5 and 12 bytes. See, and in the SDA one there are two partitions, but in the SDB there are no partitions. See, so we're going to create a partition in SDB. Okay, how we can do is we have to give fdisk command. Let me give you a syntax very quickly. So creating a partition, we have to give fdisk, then the disk name. Okay, this is one thing. Now there are three types of partition. I don't want to go in depth, but let me give you a name: primary, extended and logical. If you give you a basic idea, primary is a partition in a hard disk that is bootable. That means if you want to install operating system in some partition, this is necessary to install that partition, or that partition is primary partition. In the Windows we have C drive. C drive is a primary partition for us because that is bootable partition. We have to install some operating system files and operating system. Extended and logical are not bootable partitions. That means if you want to install operating system, you can't create this two type of partition. And the logical partition is basically made for storing data in an organized way. Now what does it mean is, let's say you have three type of servers, maybe FTP server or another server. So if you want to maintain file per server wise, you can create logical partition in a hard disk, and per partition wise you can store data of these servers. I'm not going in detail about that, but yeah, primary partition you can create only 3 or 4 I guess in you can say in a hard disk. Now what we're gonna do is, if you want to create an extended partition, we will see how to create. Let's move. So let's move fdisk. I'm giving a name of the drive, that is SDB, and I'm going inside this. Now if you want help, you can press M. See, it's saying to create a new partition we have to do and. If you want to save a partition, C, W, verify the partition table, V, something, everything is there. So now what I'm doing is I'm pressing N, okay. It's saying you want to create a partition type P or extended. See, in the down it said to me, and 4 partitions we can create in a primary, as a primary. So I'm default is P, so I'm hitting enter. Now it's saying what is the partition number, default is 1, I'm going with that only. You can change it from first sector. Now if you see, it's starting from 2048 sector. That means around 4 kilobytes of memory it's wasting. Now it's not wasting. What does it means for that 4 kilobyte? I will explain you why that is reserved. So but as of now I am going with the first sector, and default is the last one. So I don't want to create a single partition. So what I'm doing is I am giving plus sign, okay. Then I want to create a partition of size, let's say 4 gigabyte, okay. One is creating a 4 gigabyte, let's say it create a 2 gigabyte. Enter I'm doing. Yep, it's if I do V to view my partition, C, remaining is this, allocated is this. Now again I'm pressing N, default P, yeah, P, default partition number 2, yes 2, and it will automatically pick this C, because before that we have already created one partition. So I'm doing first sector, yeah, last sector I'm creating a partition of 4 gigabyte, okay, done. And now see 4 gigabyte is set. Now I'm saving this partition with the help of W. See, it's saying syncing disk. You need to do one more thing before, after the creating a partition. There is a command called depends from version to version of operating system, but partprobe is normally command that is working in the Linux 7 and 8, and then the disk name you can give. So this is basically a command to load the you can say drivers of those hard disks that or the partitions that we created. So partprobe, I'm doing dev sdb, okay, done. Now if I do lsblk, you will see 2 gigabyte and 4 gigabyte. 2 partitions are created automatically, okay. Now let's move back to again to the drive. Now create one extended partition. Default is P, I am doing E. Default 3, yes. Default first sector, yes, and I want to create till end. So if you calculate 4 plus 2 is 6, it will create extended partition of approx 2 gigabytes. And W, and I'm doing partprobe of this, and lsblk again I'm doing. See, it's of only 1K. Now why this is 1K? Because the reason being is extended partition have some limitations, okay. That's why we are not using extended partitions more. So basically the size will not be properly, we have to what I'm saying, let me go again back to this and I will explain you there. Now see, 2 primary already created, 1 extended. Now after 3 are created, 1 is free. It's saying you can create logical partition also, okay. Now I'm doing, okay, L, first sector is this, default is still last, okay. See, 2 gigabyte is set. Now here we are using 2 gigabyte. Extended Y is of only 1K. So let me explain you before, let me save this. Okay. Now if you see 2 gigabytes. So if I explain you, partition we can create, primary partition we can create of any size that we want. Basically extended partition is made up only for, please focus on my word, extended partition is only made or only created to create a concept of logical partitions. We directly can't create logical partitions. To create a logical partitions, we need extended partitions. Okay. Now the extended partition is created of 1K only. Now why only 1K and why we are creating 1K only? The reason behind I will explain you. But if you want to create a logical partition, you can create an extended partition, and inside that extended partition, the logical partitions are created. Let's say this 2048 memory is reserved. Why? I will tell you. And 2 partitions we created, 1 and 2 that are primary. The third we created is basically extended, and inside this extended only, whatever the space is remaining, let's say 2 gigabyte is remaining. So inside this 2 gigabytes, by using this third extended partitions, we can create as many as logical partitions we want. So there are always a fixed number. I'm not telling infinite. Maybe 40 or 50 around we can create a logical partition in this 2 gigabytes. Even the one we can create of size 2 gigabytes or 40 we can create, let's divide 2 gigabyte by 40 and whatever the number is, we can create that out. But the third partition, extended partition, is because to create a logical partition. Now let's come to the size. Why the size is reserved in the hard disk in multiple forms. Okay. So this is 2048. Then one partition, then 2. That is 2 gigabyte, 4 gigabyte. And then you can think of like 1K extended partition, and inside this partition only we are creating few logical partitions. Now this is reserved something for called inode table. Every hard disk will store or we'll have this concept inode table, and by default 4 sectors, that 512 into 4, that is something around 2048 bytes or 2 kilobytes, you can say. So it's always reserved for a concept of inode table in a hard disk only. So very from 0 sector to 20 or for till the 4 sector basically, that is 2048 bytes from 0 byte, this size is always in the hard disk is reserved for inode table. Now why we need inode table is because whatever the files are getting stored in the partitions, or how many partitions are created, or what files are stored in those partitions, so every detail about those files we want to store somewhere, and to store those details of files we need some space in hard disk only, because we want to store the detail also permanently, not temporary. If we want to store temporary, we can use RAM, but we want to store it permanently. That's why to store the details about the files permanently, we need some space in hard disk only, and that space basically coming from this hard disk first 0 byte to 2048 byte, and there in this space we are storing the file information. Now why it's necessary, or why inode table is necessary for us, is you can think of inode table is equals to the index page. Now if you want to access the file called, let's say my.txt, okay, second you want to store it like my2.txt, you want to access these two files as a human. So you will come to the OS. OS will not move all around the hard disk, because let's say it's a hard disk of 1 terabyte. If you search this file, two files, it will take 1 day whole to search this file or to open this file, because OS have to search the whole hard disk. And what about these files are stored at the last stage or the last sector of hard disk. Then after completing all the sectors, once OS reaches to the last sector, then only he or the OS can open these files. So it will take around 1 day at least, because read-write speed is very slow of hard disk. That's why in inode what we'll store is, let's say there are few columns: file name, file size, okay, date when file is created, date when modified, who created this file. So this and multiple options will be stored in that inode table. So let's say file name is my.txt, my2.txt, file size is 1 gigabyte, let's say 2 gigabyte, date when created, when, and one more option or one more column is there, sector, in which sector this file lies. So what OS will do is, as a human, we want to read this file, this request go to the OS. OS will go to that hard disk inode table and check like my.txt is stored in which sector, my2.txt is stored in which sector. OS will directly go to that sector and will open or read that file, or will show it to you. It's like an index page. You want to go to the lab experiment number 5. So instead of searching all the pages, what you will do, come to the index page, check the page number, go to the page number. Same the inode table concept is. Now if you want to see the inode table, we can use one option in the lsblk also. So in the lsblk we have an option of -i. No, in this we can't see. So I guess in the df-i we can see. Yeah. So if I show you, Dave SDB is not showing you here because it's not mounted yet. But I will explain you what mounting means, because if it's not mounted on some folder, as I told you, human can't access the device directly. We can only access the files or devices that are mounted on some folders, because as human we can only access files in some folders. But if I show you with the -i option, leave about SDB. But if you check for SDA1, see the inode size is this much of is used, this much of is free. If you check this, the inode size is this much is used, and this. Now if you see, this inode size is different depending from this type. Now what does this type means? I am coming to this topic only. This leads to further another topic, that is the rule number second to step, the step 2 I told you. So once the partition is created, I told you we have to format that partition. Now why we need to format that partition? Okay, so formatting a partition is just equals to creating an inode. That's it. No other use of formatting a partition. If you want to create an inode table in that hard disk for the files stored in that hard disk, to store the information of those files, we need inode table. And if you want to create an inode table, we want to format the partition. Now there are few types of formatting types, or you can say formatting extensions. Those are like ext3, ext4. If you are using Windows, there is a file type called ntfs, xfs, tempfs. Multiple things are there. Now what is the difference among this format partition? I'm not going to explain you here, but you can check out on the Google or somewhere that what is the difference between these formatting partitions, like format types. Okay, but if I explain you a very small thing and a very general, let's say ext4 is there, ntfs is there. So if I want to install, or if I want to store a file more than of, let's say 40 gigabytes, okay, so you can think of it like ntfs. If we format a partition with ntfs, we can't store a single file of size 40 gigabyte in ntfs formatted partition. So there we can use ext4 partition. So if you want to store a single file of this much of big size, we can use this partition. Second, if you want to store a file size of only 1 byte, let's say ext4 is not getting supported, this thing NTFS is supporting. So those are the differences. But when you format a partition, the formatting a partition is nothing but a simple creating inode table. Okay, so let's see how we can create a partition and what type of partitions are available in our system. So if I press mkfs, see, it's given me multiple options. Okay, if I want to see all the partition type available or the format type available in my system, I can use dot and I can use tab 2 times. See, btrfs is there, ext2 is there, ext3 is there, ext4 is there. So ext4 is the extended version of 2 and 3. See, xfs is there, vfat is there, fat is there. So multiple type of partitions is there. And if I show you just only a single table, you can reference this. Okay, formatting nothing but it's creating just a basic inode table. So from here you can read. See, this is the grade basically. Basically you can say a table comparison somewhere. If I get, I will show it to you. But yeah, from here also you can see by which type to use for which use basically. Now we will see how to format the partition. And if I show you df-ht, see, hdb is not showing me here till now. Okay, but if I go and do mkfs, or if I show you fdisk-l, and if I grab hdb, you will see these are the partitions. Okay, and if I do directly this, okay, and I can show you. Let me go mkfs dot ext4. I'm using ext4. Now I have to give div sdb1. So keep this thing in mind. This is the hard disk. 2048 is reserved for inode. We created partition. Logical is created, and this logical is created with the extended help. Okay. So we can't format the whole hard disk. It's we can do that, but like why we are doing that? Keep like think in your mind. There is no use of formatting the whole hard disk. Instead of, what we can do is these 2 partitions we created, 3 partitions we created. Okay, but extended we created only for logical. So if we keep or if we count 1 primary, 2nd primary, 3rd extended, that is only for creating logical. But in actual the partition is logical only. So 3rd logical. So 3 partitions are created. Instead of formatting the whole hard disk, we have to always format a partition. So it's like hard disk, create a partition, and that partition we created, format those partitions. Then the 3rd step is mount those partitions, because as human we can't access only the drives and other things. Okay, so I'm doing C, it's done. Now if I do, let's say I'm doing for XFS, and if I do SDB2, see, it's done. I formatted 2 partitions just now. From here we can't see, I guess. The only way we have is LSBLK. See, somewhere we can see in LSBLK also how to check. 1 second. I can use inverts, output pairs, list, permissions, discard, bytes, nodes, include, help, permission. You can check, guys, like but yeah, if I want to explain you, we just created a partition with this format. In the df we can't show, because before we mount we can't see in the df. Okay, this is one thing. The last thing I want to explain you, that extended we created, okay, that is of 1 kilobyte of size. Now why this size is, you can think of like extended partition is again just equal to hard disk only. You can think of like this is a hard disk, 2048 for inode, 1 primary, 2nd primary, and this is, we created the full size as extended partition. If we create any remaining space or remaining device or remaining partition as a type called extended, that partition will work as a full hard disk. And that 1 kilobyte you can think of is again like a general table or node inode table only. So but that inode table is of with respect to those only logical partitions. Okay, and this 2k is with respect to full hard disk inode table. Okay, this contains information about this 2 primary, 1 extended, and also about the logical also. But whatever the extended partition size is 1k, that 1k partition size is only with respect to those logical partitions that gonna create in this free space or in this free disk space or free extended partition. So extended partition is nothing but like again hard disk, inside which we can create multiple partitions, but not primary and other things. We can create logical partition inside an extended hard disk. Now the step 3rd is how we can mount and use those partitions, that is I will be going to discuss in the next video, because mounting is temporary. How we can permanently mount with etc fstep, that is again another topic. So this thing I will explain in the next video. Yeah, that's it for all about this video. If you like the video, subscribe to the channel, hit the like button. If you have any doubts, you can reach out to me on LinkedIn, or you can post your doubts in comment box also. Thanks for watching the video.